Okay, so today we're going to be looking at quadratic formula and how to do quadratic formula. So we're going to take this step by step. This is just video one. This is just kind of the introduction to it all. This is for work on Tuesday, November 10th. Okay, so this is Tuesday, November 10th. All right, so on this, so quadratic formula, you have to know and memorize this, okay? Super duper important, okay? So make sure you circle it, highlight it, make sure you memorize this. The more we work with it, the easier it is going to be to memorize it. We're going to start off by doing our discriminant, which we've talked about before. So your discriminant is your b squared minus 4ac, and if you notice, that's what's underneath the radical here. This tells us what type of solutions we're going to have. So down here is the chart. This is a little bit more detailed chart than the other one that we've had. So I kind of want to go over this just real quick. So if your discriminant is greater than 0 or it's positive, you have two different things that can happen. So PS stands for perfect square. So if you get your discriminant and it is a perfect square, that means you're going to have two rational solutions, meaning you're going to have a whole number or a fraction as an answer. If you get a positive number like 40 and it's not a perfect square, then you're going to have two irrational solutions, meaning you'll have a radical in your answer. If it equals 0, these are my favorite because it's really easy. You just have one real solution. It's the double solution. It's your double root. It means your vertex is on the x-axis. And then if it's negative, that means you're going to have two imaginary solutions, which means you'll have an I in your solution, the letter I in your solution. Okay? So let's practice some of these. All right. So on the first one, an example is given to us, right? And we're just going to follow this through. Something to remember is that you always need to check to make sure that your equation is in standard form and that it equals 0 before you start working with it. Okay? So this is just breaking down how to find the discriminant and to figure out how many solutions we have. So on this first one, my A value is 1, my B value is 12, and my C value is 36. So then if I put that into my discriminant, right, my b squared minus 4ac, so this would be 12 squared minus 4 times 1 times 36. Now remember, when you put this on the calculator, it needs to look exactly like this with all of these sets of parentheses. That way I can guarantee to you that you have the correct discriminant as an answer. Okay, so if we put this on our calculator, we end up with 0 as our discriminant. And then we said from the chart on the front, if we have 0, then that means we have one rational solution, right? So that's your double root, okay? Like I said, when discriminant equals 0, that's my favorite. All right, let's look at number 2. So number 2, we're in standard form. It equals 0, so we're just going to go ahead and start. So my A is -5, B is 4, and C is 1. Again, put it into my b squared minus 4ac. So we're going to have 4 squared minus 4 times my A is -5 and my C is 1. So once I work that out, put that on your calculator, you would get 36. Now, this is a positive answer and it's a perfect square. So that means I'm going to have two rational solutions. Okay, so you're going to get two numbers, either a whole number or a fraction. All right, number 3, before we can even start looking at that, then we got to know that if we notice this does not equal 0. So you have to make this equal 0 first. So we would add 9 to both sides. So then I would have x squared plus 2x plus 5 equals 0. You got to be really careful and make sure you notice that before you start trying to do your discriminant. So this would be 1, 2, and 5. So b squared, 2 squared, minus 4 times our A is 1 times our C is 5. So when we work that out, we end up with -16 as our discriminant. So if our discriminant is negative, that means I'm going to have two imaginary solutions. All right, so two imaginary solutions. That means I'm going to have I in my solution. Okay? All right, what I would like for you to do is to pause the video really quickly and go ahead and try 4 and 5. And once you're done, unpause the video or play the video again and check and see if you got the correct answers. All right, so here are our correct answers for that. So number 4, we should end up with our discriminant is 1. So we have 2 irrational solutions, meaning we're going to have a radical left in our answer. And then for number 5, you get negative 20 for your discriminant, which ends up being that you're going to have an I in your solution. So 2 imaginary solutions. So hopefully you were able to get those. All right, so now we're going to move on to actually putting this into quadratic formula. Okay, so we flip on over. Let's look at number 1. Again, check to make sure that it is in standard form and equals 0. We start off every single time. I want you to find your discriminant, right? That's step 1, is to find your discriminant. Okay, so this is step number 1 every single time. So I would have b squared, so 8 squared minus 4 times my a is 3 times my c is 2. So if I plug that on my calculator, and I would encourage you to have your calculator out and working this to make sure you're getting the same answers as I am. So this would equal 40, right? So that's positive, but it's not a perfect square. So we're going to have 2 irrational solutions, right? That means we're going to have a radical left in our answer, okay? All right, step 2. Step 2 is to plug in. These type of problems we call plug and chug. You got a formula, you plug in your answer, your numbers for your letters, and you chug out an answer. So step number 2 is to plug in all of our information into the quadratic formula, right? Remember, quadratic formula, negative b plus or minus the square root, b squared minus 4ac, all over 2a. You might want to write that down on your paper just as a reminder, okay? All right, so we're going to start with our negative b. So my b value to start with is positive, so now it becomes negative. So negative 8 plus or minus square root. Now, the nice thing is I don't need to fill in the numbers for b and a and c and all this stuff. We've already done that. We did that here in step 1 with our discriminant. So I'm just going to write down under my radical what I found for my discriminant, which is 40. All of this over 2 times my a value, which is 3, so 2 times 3. Okay. Step number 3 is going to be to simplify our radical. So if I look at this, 40 is not a perfect square, right? So remember what we talked about finding, simplifying radicals. I'm going to do my factor tree. So 4 times 10. This breaks down in 2 times 2, and this is 2 times 5. Pairs come out. So I have a pair of 2's, so 2 comes out. And then my leftovers, I'm just going to multiply together. So 2 times 5 gives me 10, so they stay in jail, right? Remember we said our radical is our jail. To come out, you have to have a partner. Whatever's left over, whoever doesn't have a partner, you multiply them together and they stay in jail. All right, so when I rewrite this, I'm going to substitute in, instead of writing radical 40, I'm now going to write 2 radical 10. So step number 4 is going to be to simplify out what you have left. So we have negative 8 plus or minus 2 radical 10 all over 6. Okay? All right, part of step 4 also is to simplify, right? So we are going to look at these 3 numbers. Do not touch what's underneath the radical, okay? So that stays radical 10. There's nothing we can do. Again, remember, 10's in jail. We can't go visit. We can't break them out. We just leave them alone, okay? So if I look at negative 8, 2, and 6, what number can I divide all 3 of those by? You're right, 2. So I'm going to divide all of 3 of these numbers by 2. So negative 8 divided by 2 becomes negative 4, plus minus 2 divided by 2 leaves me with 1. We still have our radical 10. And then 6 divided by 2 is going to be 3. So again, we divided everything by 2. All right, so when I look at this, now this 1 right here, you can write it or you don't have to, because 1 times anything is just going to be that value. So you don't necessarily have to have that 1 there, okay? So we write our final answer as negative 4 plus minus square root of 10 over 3, okay? Now, this is it. This is your final answer. That's all I need you to write. But I do need you to understand something. This is actually 2 solutions, not just 1. Right? This is negative 4 plus the square root of 10 over 3. There's 1 solution. And then negative 4 minus the square root of 10 over 3. It's the plus and the minus. This symbol right here just shows that we have two separate equations, okay? You do not have to write it out like this. This right here would suffice as an answer, and you would most likely see it written like this anyways, okay? All right, that's question number 1 done. Okay, let's move on to question number 2 and let's look at that one. All right, so again, we start with discriminant, okay? So when I start with discriminant, I have my b squared, so 8 squared minus 4 times negative 16 times negative 1. So if I put that on my calculator and I work that out, I actually get that my discriminant is 0. Woohoo, we like this one, right? This is the easiest one. So if my discriminant is 0, that means I have one real solution. Okay? All right, so step 2, we're going to plug our information into the quadratic formula again. All right, so we've got negative b, so be careful. Remember, you always got to take the opposite of what your b value is. So here it's positive, so it's going to be negative 8 plus minus the square root of 0 all over 2 times our a is negative 16. Okay? Step 3 is to simplify our radical. Well, square root of 0 is just 0, right? So if I plug that in, I'm going to have negative 8. Now, plus or minus 0, I don't really have to write that, right? Because plus or minus 0, it's just still going to be negative 8. So there's no need to write that plus or minus 0. And then on the bottom would be negative 32. Step 4 is to simplify. So if I simplified this, a negative over a negative makes it positive, and 8 over 32 simplifies down to 1/4. So our solution is 1/4. So what that means is if I were to graph this parabola, it would touch right here, and that would be 1/4 right there. That your x value there would be 1/4, and it's the vertex that's touching there. Okay? All right, we are going to skip on over. I want you to look at problem number 6. So flip over to problem number 6. Oops, 6, 6, 6, 6. Here we go. All right, so problem number 6. So same process, still working the same thing. All right, so start with our discriminant. So we have 5 squared minus 4 times 6 times negative 1. Okay, if we put that on the calculator, we end up with 49. So 49 is positive, but it's also a perfect square. So we know that we have 2 rational solutions. Okay, so that means you're going to have a fraction or a whole number. All right, step 2, we're going to plug our information into our quadratic formula. So negative b, so my b is positive 5, so now it's going to be negative 5 plus or minus the square root of 49 all over 2 times my a is 6. Again, I'm just following the quadratic formula. Step 3, we are going to simplify our square root. So square root of 49 is 7. So when I rewrite this, I'm going to put a 7 there. So negative 5 plus or minus 7 divided by 12. Now, notice that I have no radical left. So that means I can get down to 2 answers, right? 2 numbers. So we have to split this, okay? We need the positive version or the plus version, and we also need the minus version. So we have negative 5 plus 7 divided by 12. That's one of our solutions, and our other solution is going to be the minus. So negative 5 minus 7 divided by 12. So we're going to simplify this. Negative 5 plus 7 gives me 2 over 12, which simplifies to 1/6. And then here, negative 5 minus 7 gives me negative 12 over 12, which gives me an answer of negative 1. So my 2 solutions are going to be 1/6 and negative 1. Okay? Again, if you know that your discriminant is a perfect square, know that you're going to have to get down to here and you're going to have to split it into the plus and split it down here into the minus and keep solving and simplifying until you get down to your final answer. Okay, so that's what 2 rational solutions look like. All right, one more example for you. Let's flip on over to number 8. Okay, number 8. All right, on number 8. Okay, so start off with our discriminant. So again, b squared, so 5 squared minus 4 times negative 5 times negative 10. So when we do this, and we figure this out, we get a discriminant of negative 175. So our discriminant is negative, which means that we're going to have two imaginary solutions. All right, that means I'm going to have an I in my answer. Okay, so step 2, we're going to plug in our information into our negative b plus or minus square root of b squared minus 4ac all over 2a, so in quadratic formula. So negative b, so it's going to be negative 5 plus or minus the square root of negative 175 all over 2 times negative 5. Okay. Step 3 tells me I need to simplify this negative 175. So I know that's not a perfect square, so I'm going to do my factor tree. So 25 times 7, right? 7 quarters make $1.75. Break that down into 5 and 5. So I have a pair of 5s. So 5 comes on the outside. 7's left over. He stays in jail. And I have to deal with this negative. So remember, by definition, the square root of negative 1 equals I. So I need to put an I in here. So this is going to go right here. I never goes under the radical. Ever, 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 ever. Never, ever. Okay? All right. So then we are going to substitute this back into our equation so we can simplify. So we have negative 5 plus or minus 5i square root of 7 all over 2 times negative 5 is negative 10. Okay, so now we need to simplify. Again, we are only looking at the numbers that are out here. We don't look at the 7 at all. So what can divide evenly into negative 5, 5, and negative 10? Hopefully you said 5. So if we divide each one of these by 5, so I'm dividing by 5, dividing by 5, and dividing by 5. So negative 5 divided by 5 gives me negative 1, plus minus 5 divided by 5 would give me 1i, or just I, radical 7, and then negative 10 divided by 5 would give me negative 2. Okay, our last thing. So now we need to see, is there anything else I need to simplify? So if I look at this, I've got a negative on the top and a negative on the bottom. So if we take a negative divided by negative, they cancel each other out, or they turn to positive. So these negative signs need to go away. So your answer here is 1 plus or minus I radical 7 all over positive 2. So you got to recognize if you have a negative over a negative, it's got to become positive. Okay? All right. So this is our solution right here. Okay? Now for Tuesday, November 10th, your homework is to complete problems 3, 4, and 5 in this packet. So again, going back to the beginning, so we're doing 3. I did not copy these very well. Put these in order. So 4 and 5 are your homework for tonight. Okay? Let me know if you have questions. Thanks, guys.